Good afternoon, everybody, and welcome along to Data Platform Down Under. Today, we've got our first session for the month because we are doing multiple sessions to start off the year. So we had two last month, we've got two this month. But for our first session of February, we've got Kevin Fiesel joining us, who's going to be taking us through approaching zero, minimizing downtime during deployments. Now, this session is being recorded and will be made available on the YouTube channel once I've finished editing it and uploading it, which I do need to do for our last session. So feel free to come along and look at any of the videos that we do have up there. Sign up on the YouTube channel. I will put the link in the chat window that you'll be able to have a look at all of the previous sessions. During today's session, if you do have any questions for Kevin, put them in the chat window and preface them with a capital Q. I'll be looking at that chat window and I'll be able to ask those at the appropriate time to Kevin. So with that, I'll hand over to Kevin and he'll take us through today's session.
All right, so I'll start sharing screen here and I'll also watch chat, but for the sake of having a couple of voices on the recording, I'll leave it to Warwick to actually ask the questions. Ask them whenever. But let's talk a little bit about approaching zero. So my name is Kevin Fiesel. I'm a Microsoft Data Platform MVP. I live in Durham, North Carolina. I have independent consultancy where sometimes I do stuff for customers. I have a day job where I'm a data scientist. And I run a blog, Curated SQL. The idea of Curated SQL is I try to find and link to 5 to 10 interesting posts per day on topics all across the data platform space. That's curatedsql.com. Let's talk about what we're going to talk about. And by the way, my screen is over here, so I'm going to keep looking this way throughout the course of the presentation. But chat, you're right here. So you're looking at you right now, chat. The goal of today's talk, we're going to minimize downtime due to application deployments. And in an ideal world, we would have that number be zero, that there would be no downtime at all whenever we have an app upgrade. And I'll talk about what I mean by application, because I'm not going to focus on here's my .NET app or my Java app or whatever, my Python app. I'm going to focus on the database development portion of things. And I will also make it very clear up front here, there is no such thing as zero downtime. Instead, we can settle for approaching zero, getting as close as we can, but we're never going to hit zero, at least not if we ever change anything. So let's talk about downtime. Let's talk about why I'm so confident that there's no such thing as true zero downtime. Now, if your website has office hours, downtime's not an issue. And by the way, I used to work for a state agency. This was quite some time ago. The website for a lot of HR related stuff was up from 9 a.m. until 5 p.m. on Monday through Friday, and then a stretch of time on Saturday. But then the rest of the time, it was down. Their website actually had office hours where if you tried to go to it when the site was down, it would give you a message that said, no, sorry, the site is down. Please come back when we are available again. And it was a big PeopleSoft implementation. Apparently, it took forever to do anything overnight. And so, yeah, they had office hours. I've never been lucky enough to actually work on a product that had office hours. My employers typically expected the websites that I worked with to actually be available throughout various times of the day and evening, and sometimes night. By sometimes, I mean always. So most websites, not like that. Instead, we have pushing for 24/7 uptime because, well, we could have customers in Australia, in the US, in Europe, and in if you combine the time zones for those three groups, you have a lot of time zones across 3 continents. North America, we'll include South America as well for this. And then Europe and Australia. That's a lot of time zones to cover for our customers. And so we don't want to have a stretch where, oh, well, one subset of our audience is down, is not able to access the site. So the question then becomes, well, how do we push out our changes if, we don't want to impact the days of all of these people? Downtime. Let's talk about what this means. And I'm going to define it this way. Downtime is any time that users are unable to access the resources they need in your product. What this means, why might you have downtime? Your hardware exploded. Servers lit on fire, which I've experienced that. It's not a fun time. The application was down due to a deployment. Kind of what we're talking about here. We had network issues. Always blame the network, by the way. DNS issues, because it's always DNS's fault. We have a lock on a resource. So in other words, I've locked a table. I've got a table lock because I'm performing some operation, and that prevents everybody else from being able to access that table. Which, if you think, hey, that doesn't sound like real downtime, go ahead and take a table lock on one of your big fancy warehouse tables and go to lunch and see how long before someone calls you and says the system's down. Even just performance timeouts. So we have a performance issue, a slow query that causes the application to time out. That's effectively downtime as well, because again, users are unable to access the resources they need in your product. And this is why ultimately I don't believe in the concept of zero downtime, because table locks are downtime. If I drop and rebuild a big clustered column store index, especially on older versions of SQL Server, that could be literally hours of time where that table is inaccessible. Even a regular operation, I'm creating an index online. There is a short amount of time where I need to take a schema modification lock. That lock will prevent access to the table. That lock can cause blocking. Hopefully that lock lasts for a couple milliseconds, but ultimately, we do have some limitation of access. Now, my rule of thumb is if you can, with a straight face, blame the network and get away with it, then it's not real downtime. So we can forgive, like, oh, it took 3 seconds to load this page instead of normally it takes 2 seconds. Or it's a little bit slower today. It must be the network is slow. If you can get away with that, then you're okay. That's where we're going for with it's technically downtime, but nobody knows. So let's talk about why we might want to minimize downtime. And users, they want to see less downtime because that means they can get their work done with fewer interruptions. If I have that website with office hours and my regular hours are, say, 11 to 7, 11 a.m. until 7 p.m., and the website shuts down at 5 p.m., I've already got a couple hours of my day where I can't work on the site. I can't do the work that I need to do. If you have downtime in the middle of my day, that means it's even fewer hours that I can get work done. Even if we have a 24/7 site, if we have downtime, consistent, persistent downtime throughout the course of a day, we're making people work later. We're making people work odd hours. We're inconveniencing our users. Developers, they get to deploy out smaller changes faster. So they get end user fixes out faster. They get to do the fun things of pushing out code. And for administrators, actually get to deploy code when people are in the office and available. Because if your level of downtime is 2 seconds, again, we can blame the network for 2 seconds delay. So we could do that instead of at 3 a.m. when everybody is asleep or trying to be asleep and your drowsy DBA is trying to push out this 700 script change set that is all of the scripts that were built up over the course of the month. And when something inevitably fails 2/3 of the way through, the developer who wrote this thing obviously is either asleep or drunk and therefore not very helpful. Personal life experience. Isn't it fun? Nonetheless, we've got benefits. We have major advantages to why we might want to minimize the level of downtime because it enables us to do more things. As you can see, we've got a lot in this session. I am going to breeze through some of the pieces of it. This is probably in reality a 90 to 120 minute session. I will try my best to get it as close to 60 minutes. We might push 65, but I do know it's the middle of the day. I'm going to try not to keep you here forever. Well, let's talk about the flow. When it comes to deployment, I like to think of this in terms of blue-green deployment, which is very common for applications. a little less common for database development. Michael J. Swart does talk a lot about blue-green deployment, and I like the way Michael thinks in most cases. So we are going to think about a blue-green deployment method that is slightly modified from the classic deployment process. So I'm going to talk to you about 4 phases of a database release. So we've got our database pre-release, we've got our database release, we've got the application release, and the database post-release. So we have these 4 phases, and we're going to keep those in mind throughout the course of this session. Database pre-release basically starts whenever you would like it to. It could start right now if you wanted it to. The idea of a database pre-release is we're scheduling an operation that's going to take a very long time to complete, but will not negatively affect our users. So this is a phase 1 of a multi-step process, and users should not realize that you're in a database pre-release. As a good example of this, let's suppose that I'm migrating from one enormous fact table and breaking it out into 2 enormous fact tables. And perhaps I have a couple trillion rows in those fact tables. Well, I don't want to take the amount of downtime that would be necessary to migrate 2 trillion rows out in one big fell swoop. So I'm going to try to do this in smaller batches at a time, smaller numbers of rows at a time, and against a new table that nobody's accessing yet. So I can insert into that table, nobody cares. I can query from the existing table, and if I set things up the right way, it won't affect our end users much, if at all. And so that's our database pre-release. It could go on for hours or days or even weeks if it so needs to. But eventually, we have a database release. And the database release is where things really get started, where we get interesting, because these releases, often they're going to start on a fixed schedule, first Tuesday of every month, or nightly at 12 a.m. But we could also see these run every hour on the hour, or even whenever a new pull request gets merged into the master branch, we could kick off a database release then. During this phase, we might see a degradation of services. There's no guarantee, there's no mandate that we must degrade services, but we might see it. This is where we're pushing the majority of our database changes. So the pre-release is setting us up so that our release will function as quickly as possible and minimizing the amount of time that we're impacting other people's work. And these changes also support the application release model. So as far as the app goes, I want to make reference here to the blue-green deployment model. And I want to show, without loss of generality, meaning there are other ways to do this, but I'm going to show one variant that in which we have a fixed number of application servers. Before our release, we have 4 application servers. And they are all running what I'm going to call the old code, or the blue code. This is what we have in production today. So 4 servers, all replicas. They're application servers. There's .NET applications or Python apps or whatever. Well, I'm going to take down 2 of these servers. So I'm going to take down up to half of the machines. And by taking them down, we're going to move over the people who are accessing app 3 and app 4, who are talking to those servers. We're going to move them over to app 1 and app 2. This may cause a degradation of services while we have 3 and 4 down. Depending on how many concurrent users we have hitting our servers, for the time that we're gray, well, we have half as many servers and just as many users. So we may expect a little bit of a slowdown here. But we're going to put the new code, the new application code on those servers. And during this phase, we're going to bring those green servers up and people are going to be able to access the new servers. We could have sophisticated tooling in place that will slowly redirect people from blue to green and make sure that our release is okay. But as we're ramping up our users on green, Notice that blue is still there. In other words, people are still hitting app 1 and app 2. So our database needs to be able to support both versions of the code. Well, then eventually we can take down the blue. We're satisfied that our change was successful. The application code is good. We're going to take down the remaining servers. We're going to put the new code on them, spin everything up. Everything's now green. Everything is now using the new code base. Well, once that is true, then we can get to the final phase, the database post-release. This is where we can do the thing that I love to do most, and that is to delete things. I get to destroy stuff in the database post-release. We get to drop old tables, drop old procedures, delete old data, remove unused columns. This is our cleanup phase where we get to bring some order to the chaos and sprawl of a modern database. Database post-release can go on as long as you need it to. But again, customers should not notice anything about database post-release because all the tables we drop, those are obsolete tables. Those were the ones that were needed for the blue code, but are not needed for the green code. And so those are our phases. And if we think about migration and deployment in those terms, then we can apply that to various activities in SQL Server and see how we would need to stage things to minimize the amount of downtime that we would have. But there are a few contingencies, a few things we need to talk about first, and ways to make our lives a little simpler in the process. So I have 3 key assumptions. Assumption number 1, your database code is in source control. Assumption number 2, you have an automated release process. Assumption number 3, we have a continuous integration pipeline. Let's talk about those in turn. Assumption number 1, source control. My slides say it is not mandatory, but it is really helpful. I am going to be the bad cop on this and say it is mandatory. It is critical to have your database code in source control for the same reason it is critical to have your application code in source control. This is a safety net. By having database code in source control, and what I mean by database code is table definitions, view definitions, stored procedure definitions, function definitions, even the scripting out of logins and users and permissions. Basically, if your server exploded and you needed to rebuild, or, well, if you needed to rebuild, we hopefully would have backups. But if you needed to rebuild the structure of your tables and the structure of your objects, so maybe your server didn't explode. Maybe you hear an oops coming from a cube like 3 cubes over, where the oops is that instead of dropping the table that was not in use, they accidentally dropped the table that is in use. We can restore that from a backup, but we also want to be able to have these scripts in source control. We want to be able to revert back changes to stored procedures that we also had an oopsie on. And if you have a failure, this is one more bit of a safety net. Git is, unfortunately, the source control system of choice. I was always a fan of Mercurial instead of Git. Lost that battle, but use Git. Your developers use it. Probably just use the same system the developers use, unless there's a really strong reason not to. But ultimately, if use whatever you want, just as long as you've got it in source control. Even if you're using something like SVN or VSTS, yeah, I think it's VSTS, the old Visual Studio source control system. Those are locking source control systems that aren't distributed the way that Git is. They're still viable, just rare. Nonetheless, have source control. Number 2, we're expecting some sort of automated release process because there are a couple of benefits. By not having a human deploy the code manually, we have additional consistency. We also have the ability to do this over and over and over without driving a person crazy. This is a case where it doesn't really matter that much which tool you're using. Are you using Azure DevOps? Are you using Octopus, Jenkins, GitHub Actions? You've built something by hand. You're using like Nant to deploy stuff out. Doesn't matter. If it works, It works. That's all we need. This ensures that all of the scripts go through, because when a human is manually deploying 200 scripts, stuff gets out of order sometimes. Things you accidentally fail to deploy. So this makes sure each release is consistent, and it reduces the replication mistakes. And Warwick mentions ADO or GitHub. Yeah, Azure DevOps or GitHub, those are absolutely great choices for source control systems. And if you're using Bitbucket or you're using some other system for source control, also fine. And continuous integration. So I've talked about automated release processes, and I also hinted at the idea that we may want to run this thing more than once. Continuous integration here is saying, all right, let's keep deploying. Every time I have a change, let's deploy our changes to those lower environments. And if I have a weekly release, so all of the changes need to roll out weekly, I want to be able to run the scripts that are in my batch of what needs to run, possibly more than once. So I want to write my code, my deployment code, in such a way that it is rerunnable. That way, if there is an error, then we can run all the other scripts and then fix the error and run the ones that we need again. If we do get things out of order and need to fix things, having the scripts be rerunnable will reduce the pain. So that's more of a helpful thing than a mandatory must get done thing. But by having rerunnable scripts, idempotent scripts, where every time you run it, you end up in the same state, the same final state, regardless of where you started, this is going to make life a lot easier for that database code deployment process. Those are the key things. These are some helpful things that I've found minimize the amount of downtime that we would need. Enterprise Edition has some nice features. For example, I can rebuild indexes online. Can't do that in Standard Edition. I can partition tables, which there are certain operations where table partitioning, by merging out old partitions, I can clean out old data from a table without a lot of blocking. So that can make some deployment actions easier, or reduce the amount of blocking for larger scale enterprise actions. Read committed snapshot isolation. I wish that was the default for SQL Server. This limits the amount of blocking on tables. It doesn't prevent blocking, but I will say that I have not run into a situation where RCSI was worse than read committed, in the sense of where an environment could not run read committed snapshot isolation, but could run read committed. I know that there are specific use cases where read committed snapshot isolation is not a great idea. But I will say that I've worked in a lot of places and never actually experienced it. So I know people who have experienced it. I have not experienced it myself. Granted, still test. If you do turn on read committed snapshot isolation, certainly do your testing beforehand. Make sure that you do understand still that you can write to tables without blocking readers, but you will have writers still block writers. So if I'm writing 150 million rows into a table and somebody else is trying to insert into the same table, we may be blocking each other for a bit. Read committed snapshot isolation does also increase tempdb usage. So if you're already teetering on the edge of that tempdb problem, you may end up in a worse situation. So performance-wise, if you have really bad tempdb storage, there can be a problem here. And yeah, Greg mentions race conditions in the code, where RCSI can make the race conditions worse. And the real fix is to fix the race conditions and then enable RCSI. That's absolutely a possibility. I know Kendra Little has a really good blog post about RCSI versus snapshot isolation, and where snapshot isolation can work in specific warehousing circumstances as well, where RCSI isn't necessarily as good. So yeah, I would put the default as RCSI after testing. But you may end up in a weird situation where you have a problem in the code. Stored procedures. This is an area where I'm going to argue very hard in favor of stored procedures. And Developers tend not to like stored procedures, but I think that there is a way to help them understand the importance, the value of the procedure, because stored procedures act as interfaces. The interface in application development is a promise. These are the methods that, or the functions that are going to be available on this class. So we have certain methods or functions. We're going to make them available. We have certain promises about the shape of the inputs, the shape of the outputs, and some idea of what it's going to do. And there's another promise that you're not going to have to care about the internals because I'll handle that for you. Well, with a stored procedure, we have a set of inputs, we have a set of outputs, we have a promise of what it's going to do, and also a promise that you're not going to have to care about how I do it because you're just calling the procedure. So we get a consistent interface. And this also allows us to refactor the code within a stored procedure without modifying the application code. And that could make a pretty big difference, and especially when we consider database release comes before application release, because we need to be able to support old and new variants of application code. So I can't simply modify an existing stored procedure and make a change that the old app code couldn't support. So basically, stored procedures, they also allow you as well to see explicitly where you need backwards compatibility, because you'll have, most likely you're going to end up versioning procedures. And we'll talk about that in the demos. So Warwick mentions on a site doing an SSRS migration, the report developer had no stored procedures in use and had code in each report. The excuse was I'd have to deal with the DBA to make a change to the report. DBAs are scary. And some of that is our own doing, but yeah, I'm going to not be mean there. But look, we're adults. We're supposed to be able to talk to people sometimes. I hate it as much as everybody else. I try to avoid talking to people as much as everybody else. But, at some point, it's part of your job. Okay. There's a similar catch to, a cry in most shadow IT activities. Absolutely. Database tests. Not mandatory. Reasonably important. Very useful. They give you some extra dose of confidence. If I run through these database tests, if I've made a change, like I'm refactoring a stored procedure, I can run through the tests and make sure the behavior is still the same as it was before. So a little bit more experimentation without additional risk, additional safety net. T-SQL-T is basically the player in terms of database test libraries. It's fine. There are limitations to what you can do with it, and I think those limitations hit fairly quickly once you get past the basic scenarios, unfortunately. However, you could just write a bunch of in-unit tests or X-unit tests, basically testing in a different language and executing and making sure that the behavior of these procedures are the same as before. So we're not stuck having to use one particular style of testing, and maybe the application developers can help out with this part. All right, now we're going to get into the meat of the talk. I'm going to start with stored procedure changes, and we're going to go to Azure Data Studio and basically live there for a while. But I want to talk through the slides because I'll be giving you a link to the slides at the end of the talk. And the intent of the slides in this section is we're going to talk about what scenarios we cover. I'll have a demo, and then we'll have a quick recap. For each one of the scenarios that we cover, I'm going to tell you what you do in each phase. So we have database pre-release, database release, application code release, database post-release. And we'll do this, as you can see, for a lot of cases. So I'm going to zoom all the way through all of these because we're going to see it in code. And I think it'll be a lot nicer that way. And then we'll come back to the slides at the end, depending on time. And I'll talk a little bit about case study. All right. New stored procedure. I am creating a brand new stored procedure. Well, I'm going to use the creator alter syntax for this. By the way, this was introduced in SQL Server 2016. Very nice addition. If I have a procedure called get incident codes, I'm going to modify it, but I don't have it. This is brand new. Because it's brand new, I can do it in the database release phase. Nobody's calling this stored procedure yet, so we're good to go. In my code release phase, I can build out applications that call this code, and I'd be able to run it. I'd be able to see the results. All right. By the way, one thing that I don't like about Azure Data Studio that I need to change, it's actually a Windows problem. Shift Windows R is supposed to hide this screen. Unfortunately, Shift Windows R has become the shortcut for some snipping tool that I don't use that's built into Windows. So I'm going to have to drag this down until, yeah, it used to work. It still technically does work, except that the snipping tool intercepts it. You can change the shortcuts. I just haven't changed it because I need to come up with a new shortcut that will not overlap with anything else. Rant aside, new stored procedure, no big deal. Just create it in the database release phase. Adding a column, modifying a stored procedure. So adding a column. This new column, here, let me show you the old procedure. We have a few columns from Raleigh 2014.incident code. Well, let's say we have this incident code description and incident type, and I want to add something else. I want to add this incident type. So here we have the ID. Here I'm going to add the description. And to do that, I join to the incident type table. And for this, we're altering the procedure. We are adding a new column. The new column is at the end of the procedure. Why is that important? Sometimes it's not important. For well-behaving applications, it is not important. However, some applications read the list of columns and have numeric subscripts to reference the column number. So this would be 0, 1, 2, 3. Well, our old procedure had 0 as incident code, 1 as incident description, 2 as incident type ID. If I change this ordering and we have application code that is using numeric scripts or subscripts to reference columns, then this could be a breaking change. For sane, modern applications, this is like .NET 2.0 stuff. So, modern is a very broad term here, but we could reference incident code as a dictionary value. And now we're searching in the dictionary for the value named incident code. At that point, we can add this column, this incident type, wherever we'd like it. So if you know how your application code behaves, you may or may not need to have new columns be at the bottom. If you do include it at the bottom, then what will happen is your new application code can reference the new column. The old application code only knows about the first 3 columns and everything else has stayed the same. So we're in good shape. This goes in database release. It's just a change. But let's say I want to remove a column. Now things get a little different because I used to have incident description, but let's say we don't need incident description anymore. So we're going to remove it. And we'd think, oh, I can just alter the procedure and remove the column. But the problem is our current application code expects description. Our new code will not expect description. But while we are deploying out the new code, we don't want some users to get errors that, hey, incident description is missing, column not found in the application code. So to resolve this issue, we're going to create a new version of the stored procedure. This version of the stored procedure does not have that missing column. So in the database release phase, we have the new stored procedure. We have get incident codes. We have get incident codes 0, 1. This feels like, oh my gosh, this could explode out into combinatorial madness. In practice, in working with this, the highest numbers I typically see are in like 5 or 6. And usually it'll be no number or 1 or a 2. So you don't tend to see a lot of changes that would require versioning. But when you do, we version the procedure In the code release, we release our application code that calls this variant instead of the original. And then our post-release phase, we're not using the old one anymore, so just drop it. So now what we have in our database is get incident codes 0, 1. We no longer have the original. And so we don't have duplicate stored procedures. We just have the one stored procedure that gives us our results. Let's say we want to change an input parameter. Well, this can get a little tricky. Like if I have get incident code 0, 1, and now I want to say, hey, let's filter by incident type ID. And I want a simple where clause. I could add it to my application or to my stored procedure call. The problem is existing application code is probably going to fail. Sometimes an application is smart enough, especially if you have a default parameter, it can potentially be smart enough to know there is no input parameter set, so use the defaults. Most of the time, though, we probably need to version. So this is a case where we probably need a new version because we have changed the input signature. We have changed the promise of what we expect. And in our code release phase, we have the new version of that change, that stored procedure. Our application code is going to call the new stored procedure. And then in our database post-release, we get rid of the old procedure. So it all ends up working. Now, what happens if maybe instead of a regular parameter or multiple parameters, incident type ID, incident code, however many parameters we have in our input, what if we use a table valued parameter instead? Will that change anything? And the answer is yes. Just it will change things. Just it won't make it easier. So first, I'm going to check to see, do I have an incident type, which is a very unfortunate name that I have given this. We're going to have the incident type, but a type for incident types. And this incident type will be a table type that will have an incident type ID. And I am going to create this type. So I need to make sure it exists before I create the procedure because I'm going to mention incident types as of this user-defined table type, and I will make it read-only because we need that for an input parameter. And this will join to my incident types type, and then retrieve all of the values for whatever set of incident types we send in. So that way I can send in a list of incident types instead of a single one. So, okay, we run this. Everything's hunky-dory. This was all done in the database release phase. And then our application changes. Our application, then we say, now I want, instead of just sending in the type, we have this join to the incident type table, but the thing is, in our application, we actually know what the incident type is. We have that list saved. So I need to get the incident type description back, but this join is really expensive. And I want to take out that join, but I still need to get the contents of the result back. So how about I send you what the value should be, and then you just display that. And that's what we're going to do here. We're going to create a new type with incident type ID and the description of the type. I cannot modify a type, so there is no alter type statement. We can create, we can drop. Well, if I drop the type, there cannot be anything referencing it. So this procedure is referencing this type. So I can't drop the type without dropping the procedure. But I can't drop the procedure without breaking my code and potentially having a negative impact on users. So I need to create a new type. I have my new type that has both of the input values, and you'll notice get incident code by type list, get incident code by type list 0, 1. Even altering this type will probably break your application code. If it does not break your application code, cool. You don't need to version. Most application code will break because the generator will say, hey, you should be sending me 2 input parameters. You're sending me 1 input parameter because your code is still expecting this. And that will cause a syntax error at runtime. So we probably need a separate procedure. We definitely need a separate type, a table type. And in our code release phase, we push out the new code that calls this new procedure and knows that the input signature requires both the type ID and a type description. Once we're done with that in our post-release phase, I can drop the procedure, then I can drop the type. So I cannot switch the order for this. It has to be a very specific order, otherwise you will get failure. Okay, it's basically an argument for JSON parameters instead of table types. I mean, you could do that. You could do that. If I were really trolling, I'd say XML parameters as well. But thankfully, I'm not really trolling. Yeah, JSON input parameters could be viable in this scenario, as long as your application knows how to handle that. And that's, again, depending on how sophisticated or well developed the application is, or what the underlying engine for the code will allow the developers to do, you may be able to use JSON inputs instead, shred the JSON in T-SQL, and not have to version a procedure. Then the question becomes, is there any cost benefit or cost to performance? Does that cost to performance actually matter? And how much more difficult is it for your database developers? So we have some trade-offs basically. And depending on the answers to those questions, it could end up being, yeah, use JSON, have that be a varchar input, shred the JSON in your SQL code, and when we have changes we need to make, well, that's when we get to 15, refactoring a procedure. Because when I say refactoring, I'm actually using the proper application development definition of refactoring, which means we are not changing the signature. We are not changing what we expect to get in. We are not changing what we expect to send out. We're not changing necessarily the behavior of the procedure. What we are changing is the internals. So we're changing the black box, but the inputs and outputs are still going to be the same. So let's say we have this stored procedure, and this is our exact stored procedure that we have developed in the past. We have get incident code 02. We have an incident type ID equals null, and I have a long comment. So we have our comment in the code. Set incident type ID equals null if incident type ID is 0. We have incident code inner joined incident type in here, where incident type is null. So if this is null, then check the incident type ID. In this case, I've changed the behavior. So I've said, hey, if you send me 0, I'm going to force this to be null. Well, that way, yeah, I guess in a specific meaning, we have changed the behavior of the stored procedure for that particular input. But in general, the shape of the inputs are the same. The shape of the outputs are the same. And we haven't fundamentally altered the expectations of the procedure. And thus, because we haven't changed our inputs or our outputs, we can push this out in the database release phase. There is no code change. There's no application change. There's no pre-work. There's no post-work. So it's all pretty easy. Let me close all of these now. And we're going to talk next about tables. And to talk about tables, I need some tables. So I'm going to run these. It may take a moment because let me talk you through what I'm doing. I'm going to create a large table. The large table has an ID that's an identity column. It's got a couple varchars, and I've got a primary key constraint clustered on ID. I'm going to put in 4 million rows into large table, which is not the largest table in the world, of course, but it's large enough. And then I'm going to create a large heap. That is a heap table that has the exact same shape, except that instead of a clustered index, this is a non-clustered primary key constraint. So I'm going to insert into large heap 4 million rows. We will not have a clustered index on it. And then I will have a stored procedure that gets random records. I'm going to get maybe 1,000 random records by selecting the top number of records ordered by new ID. Is this a bad procedure? Absolutely. However, the benefit to this is by forcing me to get a random sampling of all of my rows, I'm going to have to do a table scan. So I can't trick you by doing an operation that affects later rows in the series or later pages in the table, but doesn't affect early pages, and then doing a change over here and saying, look, there's no downtime. Here, I'm forcing a scan. My get procedure is going to absolutely require that the table be accessible. First phase, I want to add a nullable column. So I've got a table, and I'd like to add a new column to it, and that column may be nullable. It hurts my heart to think about it just a little bit, but it is really easy to add a column that may be null. So if I do not already have some nullable column, I can alter large table and add some nullable column that is a varchar 20 null. And this is idempotent. I can run it multiple times and still get the same result. That same result is that if I query this table, well, I'm going to get the same columns. If I select the top, let's select the top 5-star from this table just to make sure that we got enough. Yeah, we have some nullable column right here. Okay, so we've got it. Life is good. Let's close this. Next thing I want to do, non-nullable column with a default constraint. So this is not nullable, may not be null, but I am going to add a default constraint. This is a totally good default. As of, I think this was SQL Server 2012, where this became a metadata operation. Earlier versions of SQL Server, this actually would block. This would require a table lock and would require modifying the data pages directly. As of, I think it was 2012, this became just a metadata operation, which means for my 4 million rows, this took 16 milliseconds. So again, I can easily blame the network for 16 milliseconds of blocking. Nobody would even know. I don't even have to blame the network. So we have our new column. And if I select dbo.large table, we're going to see, just to make sure, we have our non-nullable column. It's got a default. It's a good default. It's a good boy. So yeah, non-nullable column with default, no problem. Do it in the database release phase. Not gonna have any major impact. But what if I need a non-nullable column, but not have it just be the default? Now we're talking about some pain. And this is what we would have to do. If I could take downtime, what would I do? I could alter the table and make my modifications directly, and this would probably be fairly fast. But in this scenario, I don't know that it would actually be that much easier, because let's talk about what we have to do. First, we're going to add a new column, and I'm going to call it some non-default column. I am going to start it off as nullable. That way I can add it during the database pre-release phase very easily. Then for each record, I'm going to update this to whatever value it needs to be. And I'm going to do this in batches. So I'm not going to try to update all 4 million at once. That is the way to madness. That is the way to extremely long waits and blocking everybody for hours and possibly blowing out your transaction logs. So we're going to do it in a batch format. We're going to do small number at a time, where small number is whatever I define it to be. And because I'm using Developer Edition, which we can pretend is Enterprise Edition, I can build these online. I can build the index online. If I had Standard Edition, this would actually block. So because I have Developer Edition, I can say online equals on and not have to wait, not have to block people while this index is getting built. So while this is running, I can execute this stored procedure, and I'm not blocked. Technically, just to be clear, it's already done. But also to be clear, there is one small point where this does block, and that is once this index has been built. This index gets built kind of on the side, and once the index is built, there is a schema stability lock that gets taken on the table, and then it becomes a schema modification lock. And then there's a metadata change that says, hey, here's a brand new index for table dbo.large table. During that time, this will be locked. This table will be locked. Nobody will be able to access it. So after that, and that operation takes a couple milliseconds. Once it's done, we can access the table again. The tricky part when I say this takes a couple milliseconds, if there's something else currently writing to the table and I need to take this schema modification lock, I have to wait until that other writer is done. If there are other writers behind me, we can have a blocking chain. So we may have some level of blocking because of another process that's writing. Maybe we've got replication running on it, or some very expensive write operation. So this is the risk that we're taking by even creating an online index. It's not a big risk, but if we're being totally transparent, that is the risk that we deal with. What about resumable index creations? Warwick asks, do you use them? I personally don't. I've not been in a situation where I've needed to use them. However, I've also not had to be a database administrator for a large database in a while. So, yeah, I suppose there may be some benefit to them if you're talking about extremely large tables. But when we're looking at rebuilds, my philosophy is if I have good enough storage, then just even with very large tables, the rebuild is happening in the background. That's not blocking anybody. It only blocks when we're at the very end and it's time to swap those indexes out. Do you ever bother to use sort and tempdb, or do you think that's of no value with regard to reducing downtime? With respect to downtime, I don't think it matters. Basically, if you have Enterprise Edition and you can set online equals on, the only time that you will have any sort of downtime for an index operation is the index switcheroo at the very end. If you have Standard Edition and therefore you cannot build this online, the entire build process will lock the table. So in that case, anything you can do to make that index faster, make that index build faster, which might be turning on data compression. It might be having the fastest storage you can get away with. In those scenarios, then we're looking at minimizing the amount of time that we're building the index. And at that point, sort in tempdb may or may not actually improve performance, but otherwise wouldn't affect how long you may have to wait in terms of end users like getting blocked. It's a pity they don't just store default values in table metadata. Then it can make sense for both a smaller table and, for instance, adding of columns with defaults. You'd have to materialize it and update the table if you changed the default for a column. Oh, I see. Yeah, because for a table, I can. So in the add a nullable column with a default, this actually does get stored in metadata, and we could look at sys.columns, and it'll show the default information. I think that's directly in sys.columns, that system view. It may be in a different system view. I know it's in constraints, but when it comes to having other sorts of default values, then yeah, it would be nice to have a little more sophistication around how those defaults get created. I think that this seems like it was we can add one and make it really easy, but as soon as we have any sort of complications, life just got really tough for the SQL Server developers. I suppose that's the case. But nonetheless, we've created an index, and I don't remember if I created the index. I did create the index. Okay. Now, how do we update? here's one way to do it. I will show a couple of ways to do it. One is I have a while loop. And while my while loop is going, I'm going to update 10,000 rows in large table, and I'm going to set some non-default column to be whatever I need it to be. In this case, it's just the first 20 characters of some column, where some non-default column is null. So let's talk about this index. Create non-clustered index on some non-default column, include some column. This index, we're going to start off, everything is null. So we're just going to start picking where this is null. I'm just going to grab the first 10,000 rows from here. I'm going to update it. And then the next 10,000 rows comes from where some non-default column is null. So it's a way of performing this update. Again, I'll show a second way of doing this as well. This is certainly not the only way that we can build a batch update process, but I will say this does work. I can run my Git procedure while I'm updating. I'm actively updating the table, and you're going to get a table lock when doing 10,000 at a time. Yes, that is true, but each batch here is going to be very short, and that's where I get back to the general philosophy of I may lock for a few milliseconds, but given my storage here, I know how fast each one of these blocks will be. Normally do about 4,000. Yeah, and I've for some systems I've had to go down to 1,000. 10,000 here works because I know that I can do a loop of 10,000 in a couple milliseconds at most. And therefore, from the end user's standpoint, they're not seeing downtime. But this is not a magic number. This is not the number to choose. It can be smaller, it can be larger. And assuming each update is in a discrete transaction, not part of a longer transaction. So locks held are brief. That is a very important point. Yes. If you had a begin tran on the outside and an end tran on the outside here, that would lock for the entire time and would not be a happy scenario. But still escalate each time to a table lock before the update. Yeah, so we could drop it down to a smaller number and avoid getting to table lock land. But depending on the storage, that may have a measurable impact on your end users. And if it does, definitely drop that number. Database release phase. So that was all pre-release, by the way. This is all stuff that can go on. Like I said, if it takes weeks to run, maybe we only run this overnight. We run this certain hours of the day. And while it's going, we're just going to keep updating. When we're done, we release any new code that needs to call the column. And in the post-release phase, I no longer need this index because that index was supporting my update. So I can drop the index. If I have application code that really depends on some non-default column, maybe I will keep this index, but we don't need to keep the index, is what I'm getting at. If we want to remove a column, database post-release, we have to update any calling code that references that column. But once we've done it, removal of a column is a metadata operation. Now, clearing out the data that was used for that column, the storage space used for that column, not done in this operation. So if this some nullable column was, say, varchar max, and I had significant amounts of data in there, this would not clear it up and free up all that space. Lob data is also special, where if you have it in the lob, you're going to have to do a separate cleanup operation. Even if it's not lob data, if it's, say, char 2400, yeah, let's say char 2400 or char 800, and I have char 800 and I use up large blocks of space, drop column will not clear that space up. You will have to rebuild indexes. Once you rebuild those indexes, then you'll have that free space again. But that index rebuild, especially if you have Enterprise Edition, can be done whenever. So it could be done as part of the post-release phase after this, and it'll just run however long it needs to. We'll have the schema lock at the very end to swap in the new index, and we're good to go. If we have a constraint on our column that we want to drop, we need to drop the constraint first, and then we can drop the column. So again, this is just a couple of metadata operations. If I want to make a varchar column longer or an invarchar column longer, so this goes from 50 to 56, metadata operation, no big deal. Now, what if I want to reduce the size? If I want to go from 56 back to 50, we know, you and I, we know this was 50. Now it's 56. Nobody's changed any data. But if we want to reduce this back down to 50, we cannot simply alter table set column varchar 50 not null, because this will lock the table. So not something that we want to do, especially on a very large table where this can take a while to run. We may accidentally be blocking for minutes or an hour. Not a great answer. So what do we have to do? Database pre-release phase. We're going to create a brand new column. That new column is the final shape of what we want it to look like. So varchar 50 instead of varchar 56. So in our database pre-release phase, we have created that varchar 50. We are also going to create an index, some column, where some other column 2 is null. So in this case, I'm finding where are all of the situations where my new column that I've created, some other column 2, is null. And that will be a filtered index. So this is another way that you can design an index to support this kind of an operation. Then I've just started scaring people because we have triggers. There is a trigger, and the trigger is meaningful and reasonably important. What are we doing with this trigger? Well, this trigger will be on large table, and it will happen after any insert or update operation. And what we're going to do is we are going to update from the inserted set to set some other column 2 equal to some other column. Not scared, but I did audibly groan when I saw create trigger. Yeah, no, it's totally fair. Triggers are not bad. However, they are easy to forget about and can have weird effects, and it's hard. It can be easy to not realize that there's a trigger that's causing a problem in code. Also, if you don't write the trigger well, you may assume that there's only one row that gets updated in here, whereas there may actually be multiple rows in the inserted set. So we have to treat it as though we have multiple rows that we need to update. So for each one of those rows, even if it's just one, we're going to set some other column 2 equal to some other column. The reason that I want to do that is if I have modified, so while we're filling in some other column 2, people are still using our data. They may still be updating our data sets. And as a result, we can't have the old value if there's a new value in there. So we have to manage that. And that's why we have the trigger. An example call, if I insert into large table, I have some column, some other column. And let me select the top 10 from that large table. We can see that some other column 2 did get set. And we did it for this type of a scenario. Can't tell you how much production code I've seen that assumes single row triggers. Yeah, and there's so many examples on the internet as well. They're just messy. If you have long-running processes in a trigger, Service Broker could be a good thing to look at. Yeah, Service Broker, that is one of the good use cases for it. Yes. Update the large table. We can set some other column. So for those rows, I have a single update, and we can see that, yeah, it did actually update all of them in order. Okay, we've got the trigger in place. The trigger is going to manage any changes or any new rows. For everything else, we have another loop. And what we're going to do with this loop, and let's reduce the number for purposes of saying we don't want to hit any row thresholds. So we're going to say while 1 equals 1, update the top 1,000 records in large table using this index. I have found that if you don't specify the index hint, because this is a filtered index, the operation may not necessarily realize that you have created a very helpful index that is quite useful to it, and will instead drive from a clustered index that will get worse and worse over time. Because what will happen is, for the first batch of rows, the scan doesn't have to go very far to find 1,000 rows. But then it's updated those. Now for the next 1,000 rows, we kind of have to scan over the ones that we've already done and then get the next batch, which again, 2,000 rows, that's not much. But when we get to 150 million rows, every iteration has to scan over more and more rows until it finds rows that it hasn't touched yet. And that's why, without a proper supporting index, this kind of batch operation will get progressively slower. It'll start out looking fine, but then it'll get slower and slower to where you're seeing ridiculously slow speeds for some of the later operations. Whereas with this index, where I have a constant filter, give me 1,000 rows where the column value is null. So where there is no column value. Because I have an index that can easily just grab 1,000 rows, I don't care which 1,000 they are, just give me 1,000. And we have this index that's available to us where I can keep grabbing. While this is going, by the way, as you would expect, I can still access data. We're not locking anything. We're not preventing users from accessing the system the way that they would expect to access it. And this may take a little while. So it may take quite a while. Endlessly amused when people think adding indexes will slow update operations. Always point out that to update something, you have to find it first. For sure. Yeah, the whole thing of too many indexes, there is a limit where, all right, when you have this many indexes, we start asking questions like, why did you use Database Tuning Advisor? But for a sane operation, having 5, 6, 7 indexes doesn't mean your insert will be slow. So yeah, totally agreed. And it's just going to depend on what is the access patterns. I may wonder if you've got 24 indexes and they all make sense, that table design may not be the best, but there's only so many fights that I can win in a given day. All right, this is going to run. It's going to take a little bit, but let's talk about what happens at the end. At the end of the show, we have a transaction, and I'm going to do this in an explicit transaction. And here's the reason. What we're going to do is drop our index. Our filtered index no longer makes sense. We're going to drop our trigger. We need to do this in a transaction because I want actually to block operations at this point. I don't want people to be able to modify this table now that I've dropped the trigger. So drop index, that's going to cause a schema modification lock on the table. Nobody can modify. Drop the trigger, then alter the table and drop the original column, the varchar 56. Then rename some other column 2 to some other column. And what we will end up with is large table will have some other column. It will be of type varchar 50. This is a lot of effort to go through when this is the equivalent. This is the version that we could run if we had downtime capabilities. So as we can see, there may be a lot of pain involved in doing these operations. So I did some work many years ago, was asked to assist the developer. When looking at the database, the size was 220 gigs. Nothing major, but 180 gigs was indexes. Yeah, that's its own problem. And yeah, it can be about taking away poor choices from the query optimizer. Absolutely. So more indexes doesn't necessarily mean good indexes. Having more good indexes beats having fewer good indexes. Having more good indexes beats having more bad indexes. But ultimately, it just comes down to where good index is what operations best support the queries that your end users have. And by doing this, we have lost some other column too, and everything looks the way we expect it to. When it comes to renaming a table, do that in an explicit transaction, and we can rename, like if I rename dbo.largetable to test large table, well, in this explicit transaction, what I'm doing as well is I'm going to create a view on that old table name. So that way, any calling code that references the original table name will reference the view. And as long as the view exists, it's okay. We're going to phase out that old code. And once we're done, everybody's using the new name of the table, test large table, instead of dbo.large table, we can drop that view. By doing this in an explicit transaction, there will not be any time period in which a user can access this table, but get an error that the table is missing by the name. So we have that in place. And I'm actually going to rename it back to large table. When it comes to indexes, I know that we're close on time. So Warwick, if we're at time limits, let me know and I'll just wrap things up. I'm not going to get through all of this.
You're good, Kevin.
Okay. All right. So what I'll try to do is maybe about 5 or 10 more minutes and then wrap things up. I'll hit the highlights here. So for indexes, if we have online equals on, Enterprise Edition makes life easy. Dropping indexes, no big deal. Just do that in the database post-release phase. There is a schema modification lock, so you will have a few milliseconds of potential blocking. For clustered indexes, again, we can create those online equals on. If you have the disk space, you can do it as an online operation, but as a warning, you'll need approximately double the disk space for this because we have our heap, which already has all of our data. We're going to create a clustered index on the side that will have all of our data, just hopefully in a better aligned way. And then when the time comes, essentially we're saying, hey, go look over here for our data in our heap. And then we're going to say, go look over here in our clustered index for our data. Well, you'll have the data in both places. Then we drop the heap, and that heap that space becomes available for use again. So rebuilding a clustered index can take additional space if you're building it online. If we build a clustered index that does not have a primary key constraint, then in our database pre-release phase, I can create my clustered index online. Database release phase, maybe we have store procedure changes to use that new clustered index most appropriately. If we have a clustered index and primary key constraint, this can lock. If I take large table and I drop the constraint and then I add the constraint, it can take a little while. So the primary key constraint itself, if I run this, in this case, didn't take long at all. It took 380 milliseconds, but potentially could last a while. Now, I know this is actually usually really fast for NVMe storage, and I can usually get away with this. This is within the range of blame the network. And the clustered index, this may take a little while. This may take longer. It may take a couple minutes, but this is also an online operation. So until the very end, it's not going to lock anything. This constraint addition will force a table lock the entirety of the constraint creation process. The reason for that is we need our constraints to be valid. And if we don't lock the table, some yokel could come in and modify our data in such a way that our constraint would no longer be valid. So we can't allow that to happen. We need to lock. For the rest of this default constraints are, does online equal on mean it uses Azure? No, online equals on means that I am not going to block access to the table, to the underlying table, dbo.large table, while I am creating the index. I will only have a short amount of blocking at the very end. So what'll happen is with standard addition, or if you set online equals off, what this means is when I create the index, while I am creating this index, I am going to take a lock on that table. And nobody will be able to read from the table, write to the table, do anything with the table. And that's going to last for the entirety of the operation. So in this case, it would have lasted for almost 42 seconds. With online equals on, what this means is we are going to create this new, make this change kind of on the side. We have our table. People can still access our table. We're going to make the change on the side. SQL Server will actually manage if there's an update to this table while this index is getting built, that update gets moved over. Sort of like what I showed in our code where we had that trigger that was moving over changes. Similar story, just handled internally, so we don't have to do it. Then, when everything's done, there's going to be a schema lock operation to do the Indiana Jones shuffle at the very end, where we switch out that old clustered index and put in that new clustered index. Or if we have a non-clustered index that we're adding in, we've got our table, our clustered index, we've got any non-clustered indexes, we have our table metadata, and we're going to update that table metadata and say, oh, by the way, here's your newest index added to the family. So that does take a few milliseconds, and that's what online equals on means. It's just saying that we can do almost all of the work without impacting existing users, without impacting people who are querying that table. Okay. That is a little bit of pain, needing to switch non-cluster primary keys to cluster primary key because of Microsoft Dynamics AX. Yeah. No, SQL will build a second index. It's a copy, and then at the end of that index build, it does a really quick metadata switch. Yeah. So Mike is mentioning in text what I mentioned in the Indiana Jones switcheroo. Default constraints, not blocking. So we can just do that in a pre-release phase, add that constraint, no big deal. Changing a default constraint, I can drop the old constraint, I can add the new constraint. This is again, actually I need to run this one first. Not blocking. When I say not blocking, again, it may block for a few milliseconds, no big deal. Unique keys do block. Same reason for primary keys, same reason for check constraints, same reason for foreign key constraints. I need to block so that nobody messes up the data underneath and makes it so that I have an invalid constraint. So for every one of these cases, if we need to add a new foreign key, if we need to add a check constraint, a default, a check constraint, a primary key constraint, or a foreign key constraint, or a unique key constraint, for those 4 types of constraint, the correct answer is build out a new table that has all the constraints that you need, create the trigger, start shunting data over to that new table. Our trigger will insert into the large table with constraints any data that gets inserted from large table with from our original table, and where we have no data in the new table, or we update where we have data in that table, or we delete where it's in here and it's in the deleted set, but it's not in the inserted set. So quick story with triggers. There are 2 magic tables, inserted and deleted. Inserted means these are all of the new changes. Deleted is here is the old or removed data. If you have an update operation, you will have a row in deleted and a row in inserted, where deleted has the original data, inserted has the new data. That means just because you're in deleted doesn't mean it was a row that was actually deleted. We have to check to make sure, are you in deleted and also not in inserted? And those are our deletes. So we have this operation, this trigger that's running. And then we also have loading in batches. And I'm going to select the top 10, however many, 1,000, 5,000, 2,812, however many rows from dbo.large table, left outer join on large table with constraints. where we basically loop through. I'm going to start at ID number 1, and I'm going to keep going until I run out of IDs. So this is a third way of batch loading, where if I have a starting point, here's my minimum ID from large table. If I have a starting point, I can build out a batch ID batch table and say, all right, well, give me the top however many, 1,000 rows or however many, and then go and process these. That will take a little while. But while it's going on, I can insert into large table. I can query large table. I can make sure I can update the table, delete. And then when we're done, we drop the trigger. We perform a series of renames. So I drop the trigger on the temp table, temp, not hashtag temp, but large table with constraints. Then I rename large table to large table underscore delete me, because at the end of the day, my code still wants to call dbo.large table. I just want large table with my constraints on it. So I need to rename large table and any primary keys or default constraints or indexes. So I'm going to have to rename all of these things and then rename the new table to large table and rename all the constraints and or any of the indexes and constraints that are already were already on the original. There's a lot of pain here. And if you say, listen, why don't you just add the foreign key? Do it during a time when nobody's using the app and just get away with it. If that's your feeling on it, I'm okay there. We may say this is a special case. Let's just take a little bit of downtime. But I did want to show you it is possible to do this. It is painful to do it, but it is possible. And just a real quick story, case study. When I was working as a database engineer, this was actually almost a decade ago at this point, but I was responsible personally for about 200 tables, 800 stored procedures. I had just come onto this team, and most of these tables had a column called client ID, and it was part of the primary key. Now, the only teeny problem with it is that it actually needed to be called profile ID, because that's what the rest of the company called this thing. And the rest of the company had a concept called a client ID that was not the client ID in these tables. So the client ID in these tables was actually profile ID, and there was client ID that existed as a totally separate concept. So this meant updating, about 150 tables and 700 stored procedures that referenced client ID without extended downtime, because we weren't allowed to have extended downtime. So how do we do this? Just a quick idea, the scope: rename client ID to profile ID on 150 tables, rename constraints, rename indexes. We want to have everything, look right at the end. There were some tables that just weren't in use, some procedures that weren't in use. 150 stored procedures, literally nobody used. Rename client ID to profile ID on about 550 stored procedures that people did use. And while we're in there, let's refactor it, because some of these things hadn't been touched in 6 years. And so I could probably make this at least look nicer, look consistent with company standards, and probably make it a little bit better in the process. Update some SSIS packages, update some reporting services things, convert some ad hoc queries, and make them all use profile ID. So we want to do this. Here's the image. Orange here means client ID. Everything used client ID. So we have our tables, we have our stored procedures that were facing code. This actually was a saving grace. Application code only used stored procedures, except where it didn't. But almost always used stored procedures. We had views and functions. We had stored procedures that didn't face the code. We had some SSIS packages, SQL agent jobs, and just some miscellaneous stuff, just stuff that was there. So phase 1, pre-release. We're not even in the pre-release yet, but we began reformatting, refactoring procedures, getting rid of the unused procedures. The way I did it, a couple ways. Look for things that are in the plan cache and the procedure cache. If it's in the procedure cache, it's probably in use. If it's not in the procedure cache, it may still be in use, but at least we don't know that it's in use. Look in the code base. SQL agent jobs, SSIS packages, reporting services reports, metadata tables. A lot of this is going to require some expertise in the systems, know what people are using, and eliminate broken objects. Because if you select from the view and you get an error, what that's saying is nobody's selecting from the view. And if nobody's selecting from the view doesn't deserve to exist. And we create lots and lots of database tests because we're going to need them. Then in the pre-release phase. So that, by the way, this was probably a matter of about 2 to 3 weeks of just doing this. In the pre-release phase, we add one new column to every one of those tables, profile ID. It is a nullable integer, and there's nothing in there yet. In the database release, we're going to put out a series of temporary procedures that take in both client ID and profile ID as parameters. Then we're going to take out all of those app level stored procedures, and I'm going to kind of nest them one layer deeper and put that logic into my temporary procedures. We're going to do is-null checks on @profile ID, @client ID. So whichever one you send me in, I'm going to accept it, and I'm going to realize that you're telling me the same thing. Then those app level procedures become shells that call the temp procedures. So here's what we've got. Our app code hasn't changed. That's one of the tricky things here. The application code couldn't change because it was way too difficult for developers to do find and replace of profile ID to client ID to profile ID. The developers could either find or they could replace. They weren't capable of doing both, it seems. I'm being mean to the developers, and I liked the developers, but yeah, this was a case where they're like, oh, this is way too difficult. We can't possibly get it done. And so the database team, we were like, screw you, we're going to get it done. And the way we did it, this didn't change, but this changed. Now we have this intermediary that says, you're telling me client ID, but really I know that you mean profile ID. So our tables have both client ID and profile ID on them, but everything else is all just client ID. In this release phase, we changed the references in views and functions to say is null profile ID client ID. This is going to slow things down. This may mess with indexes. This will be painful for a few hours. But we realized that and we were willing to accept it as the cost of getting it done. So as a result, our tables have both client ID and profile ID, and these internal procedures, these views, these other things had an is null check. Do you have a value in client ID? If so, we'll take it. Do you have a value in profile ID? Otherwise, we'll take it. All right. So we've done that. Our next part of the database release phase, we update the non-application SQL code to check as well is null profile ID client ID. That would be SQL agent jobs, triggers, stored procedures that aren't used in application, code, SSIS packages, anything else that we've got running. So we've got all of this stuff, and everything behind the curtain is checking those is null checks. We've slowed everything down for a little bit of time, but this isn't going to last for too long. The next phase, phase 3. Here's where we do the big switcheroo. We're going to swap profile ID and client ID. And the way you do that, classic development 101 renaming. Rename profile ID is now profile ID 2. Rename client ID to profile ID. Create a new client ID, and then drop profile ID 2. So we could have done 3 renames, but instead we did 2 renames, an add, and a delete. And at the end of the day, what we end up having is profile ID has the value because it used to be client ID. New client ID is null. All of our code is still working the same because we have those is null checks. Then we renamed all of the constraints, all of the indexes, and we now have this, where instead of orange and blue, we have blue and orange because we have profile ID and a vestigial client ID. We still have reference to this client ID because our views, our procedures, our SSIS packages, everything else in here still thinks client ID is a thing that exists. So we have to manage it for now, but we're going to fix that. In our post-release phase, we're going to deploy the final versions of these temp procedures that no longer looks at client ID because we know profile ID is the only ID at this point. And so we're going to get rid of that is null in the temp procedures. Then return profile ID as client ID. So that way, any application code that's still looking for a column named client ID you're going to get profile ID and profile ID as client ID. All right, new procedures, only looking at profile ID. All of this other stuff still looks at both. Our code still expects client ID. That doesn't change. Now, we update the non-app SQL code to change is null profile ID client ID to just be profile ID. Because again, client ID, that's all null. We know it's all null. So at the bottom level, we've gone totally blue. We have an intermediary layer that's still looking at both, but we needed to change the bottom stuff first because there were dependencies. So then update the views and functions, get rid of the is null check, just use profile ID, but in our select statements, profile ID and then client ID as profile ID. And now almost everything is blue. Our table still has that vestigial client ID, but we can drop the empty client ID column and deprecate any obsolete objects at this point. So we are in the final post-release phase, and here's what it's looking like. We have our new procedures, our code-facing procedures, and we're going to update our application code over time, not to use these older procedures, but instead, as the developers go through their app and they make the changes they need to, we're going to say, hey, why don't you just call that procedure instead? And we can slowly deprecate these procedures, slowly get rid of them over time. And at some point, someday in the future, which it actually took a couple of years for the final changes to make their way in, but we would have the code go blue and go completely profile ID. So that did take a while to wrap it up, but we were able to do this in a process with effectively no real downtime. We had slowdowns for about a 3 to 4 hour period, but then everything was good after that. So let's wrap things up. Zero downtime, not a real thing. However, scare quote zero downtime. This is not going to work for every company. You do need some dedicated database people. You do have to understand, what the costs are of that extra effort. But if you do have that ability to take significant downtime windows, this is going to be easier. However, if you do need to be in that near zero downtime environment, it's good to know what you can safely do without blocking customers to the extent that they can actually blame you. So, final reminder, if you can blame the network, is it really down? If you'd like to learn more, if you want to grab these slides, if you want to grab the demos, if you want to grab links to additional resources, that is all at csmore.info/on/ZDT. If you have any questions at all, I am happy to take those questions now, or you are welcome to send me an email or even hit me up on Twitter if you'd like. So with that, I'm going to say thank you so much. If you have questions, I'll stick around. Otherwise, I appreciate your time. And Mike does have a question, so I'm curious to know if it's common practice to version database object names, like stored procs with 0102, etc. I would have thought that that would be painful for the app developers because all the references need to change every time you create a new DB version. So I have run into this at a few different places, and basically this is kind of the best alternative to a painful problem, because the application code does have to change to accept that this is a new setup. And Greg mentioned a couple of times as well using schemas for different versions. So you could have V01, and that works really well if you have staged releases. If you've got like a box product that you're occasionally sending a quarterly update out on, and that scenario can work quite well too. In our case, we used schemas for a different purpose, and so didn't have schemas available as an option for being able to version. And that's why we ended up landing on add numbers at the end and just update the app code eventually. So there is a little bit of pain involved. In an ideal world where tables had the concept of versioning built in, we might have an easier time of it, but that's just kind of, you've got a couple of second best options, and That's one of them.
All right. Well, thank you, Kevin, for giving up your time and providing us with such a wonderful session today. Lots of interaction with those online. So as Kevin did mention, if you do have some questions, feel free to either put them in the chat or raise your hand and you can come off of mute and ask Kevin that question yourself. As mentioned at the start of the session, it has been recorded and will be placed up onto the YouTube channel. So you will be able to come back and watch this session again and pick up those fantastic tips that Kevin has given us. A lot of thanks. Excellent. I don't think we've missed any of the questions. Got them in real time. Well done. So if nobody has any other questions, then thank you all for participating and staying along for this session. As I mentioned, thank you, Kevin, for this fantastic session. And if you haven't already signed up for the next one in 2 weeks' time, you've got plenty of time to do that. And I'll see you all online in a couple of weeks.
All right. Thank you, everybody.